On page 21 of the Logic Structures handout, you've got several exercises that are dual alternative selection structures. These really are not that difficult. The implication is that you will have a sequence of instructions on both sides, the true and the false side of the selection. I'm going to kind of do a hybrid one. If you take a look at number 4 and number 6 on this screen, they're very similar. It's the whole determine if it's even or odd, determine if it's a multiple of 5, output a message giving the results. Number 6 is the same one, only you can only have one output statement. So addressing that, let's switch to a visual logic example that does just any of them. So at the moment, let's go ahead and run this. We have a divisor. Why did she do that first? Okay, well, let's choose 2. Then the number is 6. We get an output. 6 is divisible by 2. Great. Let's run it again. 2, 5. And this time I get a strange output of just a 0. What happened? Let's look through this. First we inputted the 2, then the 5. Is 5 mod 2 equal to 0? No, so it went on the false side directly to the output. And because nothing had ever been put in MSG, it put a 0 out there. Well, the obvious cure is that we need to perhaps copy this one, paste it over there, add a not, and now let's run it again. Divisor is 2, number is 6. 6 is divisible by 2. 2, 5. 5 is not divisible by 2. So I was able to have a single output statement simply by building the strings that would go into it in assignment clauses. Very common technique. Output statements are expensive in some computing, and to save space there may be a limitation on having too many of them. Now I'm going to show you a mistake that some people might make. They might move this statement up here. Yeah, it's going to work. But what happens if I have one that goes on the true side? If that was the case, we would put the not statement into message, check to see if it's divisible by 2, and then put the is message back into message, so it gets set up twice. It is far better to think of these as kind of a symmetry. I have my condition, I've got a true side, I do something to the variable, and I do something on the true side, and I do something to the variable on the false side. Let's explore a couple of other little things. Let's say you were perfectly happy with the 0 for the message, for the false side. I'm going to do that loop thing that we demoed early on. Set up a little variable called k, started at 1, count by ones until I get to 3. And we will have our main sequence in there. That way I don't have to keep running the thing so much. Let's see what happens this time. My divisor is 2 again. My number is let's get a little better here. 8 is divisible by 2. Okay, we're now down on the output. It's going to go up and loop around to the k equals 2 to 3. Let's type in a value for number. Let's type in 7. 8 is divisible by 2. Why did it do that? It's left over from the previous time. Let's just try this one more time. Let's try it with 3. It's still using the leftover one. I did want to illustrate that to you, that it is very dangerous to assume that something will be initialized to a default value. Yes, some programming languages do it, and yes, many do not. It's far better to assume that they will not initialize something to a default value, and then you guarantee that it is set to the value you want. Okay. Looking at the exercises, for number 1, display. Well, that means output. So it doesn't say anything about having only one output statement. So you could have 2 output statements, or you could do one using the technique I illustrated here. If a minimum data balance is under 100, assess a service charge of 15. Each one of these has some little complication that makes you think of how you're going to do the solution. There are some further on down the page too. Do as many of these as you can, and if you go into Blackboard, you will see solutions in one form or the other, either a word printout or a video on them. There are 8 of them all together. Okay, see you later.